Well, hey there, everybody. So today we're going to work on Chapter 14. And per the instructions, we're going to not only make the parts, we'll then assemble it, and then do some drawings as well. So this is probably going to be a long video, even though it's only going to be actually 2 chapters. Since I used the ebook, I can't really rotate this, so I've actually pasted that in a Word document to make this a little easier. And it's not listed, but clearly this part is metric. So we'll open up the metric template part. And I suppose we will start with the base plate, since it's top left there. And we'll do a front view drawing this profile here. So it looks like we have a overall width of 136. Kind of use that as a jump off point. Let's see, it goes down. Now, unfortunately, that line was not where I wanted it, but that's fine. Okay, so you know what? There was a gap in there too. Sad day. Okay. We'll just trim off the excess here. Put in that 136. And I think we will use this center point of this line here as our location for the origin plane. Move that back where it should be. And while we're here, I'll just go ahead and do some cleanup. I'll do some collinears. 50, 60, that's 60. 60 and 48. And our gaps are both 4. So then we can say that this line equals this line, and the same for these bottom 2. It looks like we are missing, I'm going to undo that. We're missing a perpendicular constraint here from where I drew in that rectangle. And then we need a height. It looks like it's going to be 12. Okay, so we can go ahead and extrude that both ways. It looks like it's going to be 78. So go ahead and plug that in. Next, we'll need to add these 4 holes. And since we have to do fillets and holes, and they're both going to be cutaways, we'll just do one on each side here, and then extrude it and cut it, because we would have to do 2 features regardless, but definitely of the mind of work smarter, not harder here. Instead of having to do all these holes and then filleting them, another command will just go about it this way. Okay, and they are 12 and 10. Okay. I guess technically I can mirror it twice, but I'm not a fan of that double mirror. So we'll set these to equal each other. Project this bottom edge since it's the only one left. And just for a little cleanup, I'm going to change these projected lines to construction so they're not so visible. Alright, so I got it trimmed, and we'll just go ahead and You know, unfortunately, actually, since I changed those lines, I'll have to change them back. You won't see them if they're instructions. Okay, so choose this area and that area. Cut through all both ways. We can do a mirror. For a plane, it'll be mid-plane. Okay. That appears to be it for that one. So that's base plate. We'll go ahead and make a folder and save it. You know what? We should probably make a naming scheme in case these are the same. So let's go with wheel assembly. Base plate. How's that? Okay. Alright, so next we'll do the bracket here. So let's do I have to say which view I want to do first here. I'm kind of thinking the bottom one just because it's the low-hanging fruit. So yeah, let's go with that one. We'll do a top view. Just throw in some kind of random shape like this. Oh, we just do fillets there. Okay, so the overall width is going to be 78. And we'll do the same thing. We'll take the midpoint of this line, make it coincident. Then it is 37 for the height in this view. So then we can add in our fillets, which are 12. We'll extrude at 10. And I think that given we're going to be using this in assembly, I'm going to extrude downwards. You know, honestly, I'm not very happy with the view choice that I've had, though. When I'm looking at this, this is going to be our front view, so our other part should actually be sideways. So I think that I'll actually go back in here and delete our original constraint to the origin point. Just to make sure we don't have an extra piece of geometry there, I'm going to this point that was originally there. Reproject that origin, and we will rotate. Doesn't really matter to the base point. Whoops, should have been 90. Okay, and since these are symmetrical, it doesn't matter which orientation you have it in. You could have done 270, you could have done 180, and it would have, or 90, it would have still been fine. So don't worry too much about that. As long as you know which one should be where, you'll be fine. After that, you'll have to add back in a vertical constraint and maybe some more. Let's check and see. I'm still going to use that same line for our origin point. Make sure it's fully constrained. And there we go. Okay. So now we need to draw on this plane. We're going to make this portion here. So we've got circles that are 20 and 20. And they're 48 from kind of hard to see, actually. almost looks like they're saying to that fillet. It'd really be 51 here. This one will be 40 because it's a radius circle. Okay. Poo. So now we'll draw in our lines to make tangent. What in the world? It wasn't working for a minute, I was clicking. Okay. So we'll trim, and it looks like it actually will touch the corners, so that will. Oh, be careful if you have that property sometimes where it flips. In this case, actually horizontal will be needed. And it's going to be extruded 10. It looks like it's going to be extruded 2 inwards as well. So what we'll do is go ahead and project this little circle here. Match it up to equal the one we projected. And go ahead and extrude 2 more. But we need our little hole as well. Alright. So now we can add in this little triangular portion here. We'll use the middle plane that intersects with everything. XY. I'm just going to generically draw a triangle after I slice graphics. Okay, so it is 32 by 20. So we'll make these collinear and extrude 15 symmetrically. Just so you can see, that's kind of what we're looking at. Sorry about that. Mouse is in the way. Alright, so now we just need a lot of fillets. Our spot face holes. Just forgot about those. I believe they are, let's see, 24. Huh. Okay, so they are concentric. Making sure. I had bad math in my head for a minute. I was thinking that they weren't symmetric, and I was getting very concerned. Usually your circles are always going to be evenly distributed, and of course concentric to the other circles. Alright, so weird it shows 2 selected, but weird. Okay, so we'll just press on. We have 2 times diameter of 10 spot face. It's always weird, but the whole command seems to default to the previous used. So silly. Let's see, what passes through there? I don't really know the screw size. I mean, we know it's obviously around 10. Oh, there it is, 15. I was wondering, I knew it had to be somewhere. Okay. Since it doesn't give us a value for our spot face, we really don't necessarily know. We're getting some kind of error here with our points. Oops. There we go. Because it's using previous settings, we were having a issue with the sizing. Okay, so we can put it back at 2mm. I think that more or less it's just saying use the default here, but let's kind of look at it and see if it looks visually similar. Yeah, looks pretty close to me. Let's roll with that. Okay, so now we can do all of our fillets, and they are a radius of 3. I don't know why the whole command didn't used to be so finicky, but lately it's like you basically just got to tell it what to do. It used to be you could kind of just roll the defaults if you were unsure, and it would, you know, just make life great for you, but no longer. Why you do this, Autodesk? Telling me. Okay, so we've got fillets all around, basically. So we're missing an edge. Yeah, okay. And then we've got them around this loop. And it looks like here as well. Hopefully this doesn't say it's unable to compute some of these. Right there, whenever you know it's starting to get ugly. That looks like it. This part stays the way it is. Okay, so there's that. And just to make sure, earlier, you know, we saw that 48 dimension. I want to make sure it is 48. You know, it's never so convenient that you can just. It's another thing they changed is the measure tool. It used to be a lot more effective. But, you know, so what we have here is 48 to the start of the fillet. The way I got that was obviously a radius. No matter where, if it's a radius, it's always going to be that value. So we knew it was 3 here, so I took 48 and added it to that 3. Okay, so anyhow, now that we've wasted plenty of time talking about it, let's save it. It's going to be called the bracket. So I'm going to use that same naming scheme. I'll just change the name to bracket. All right. Let's see, where's part 2? Okay, the wheel. So we'll do the wheel next then. You know, I did realize though, we need to put some materials on these. For them, I'll actually use materials. All right, so cast iron. Naturally, they put it backwards to confuse people. It's iron cast. And also cast iron. All right, so let's do the wheel. naturally this is going to be a revolve. So we're just going to draw the profile. And it's actually pretty basic. No fillets, except for on the inside, so we'll just draw roughly this little shape here. Dang it. Every time, I tell ya. I wish there was a little more snappiness, though, on the lines for real. It's a bit of a pain when you're trying to draw, and sometimes it just gets crooked, and then you don't get all your implied constraints, and suddenly life is very, very difficult. Okay. So we have a diameter of 100. So here's our starting point. And that is supposed to be my very, very accurately drawn center line. It may be hard to tell, but that's what I was going for. Alright, so center point constrained to origin point. Let's make this horizontal. We will make the endpoints of the center line align to the edges of our wheel center portion, for lack of a better term. And then we'll set our diameter of 100. And it's hard to see, but it looks like we've got 24 and 36. Alright. Move this little guy, big guy, out of the way. And oh, okay, it just gives 3 value here. And surprise, surprise, it's slanted. They tricked me, guys, they tricked me. Okay, so delete this. And perpendicular. That one will be safe. We can fix it if we need to. And then let's just put an angle on there just to give it a kind of a template. That's a miss perpendicular here. There we go. Alright, so it is 5 to the vertex is what it's trying to imply there. Fillet vertex. So now we can say that this portion is horizontally aligned to this portion. This line is equal to this line is equal to this line is equal to this line, because I believe they are. They are. This line's vertical. We have a 50 width and a 10 width and a 38 width. That backwards. This one's 50. And this one's 38. Alright, so it says we're missing one dimension. I'm not really seeing a blue. Oh, there it is. Okay. We need one collinear. There we go. Alright, so we'll revolve this. And then we have no fillet designations, I don't think. Okay, so R3. And we have it here, here, and then of course on the other side the same. So here and here. I'm gonna double check. There. Okay. And rinse and repeat. Alright. So let's change that material to cast iron. You know, I guess we could talk about this, but some of you may be wondering, why is there 2? That is because this is the material browser selection options. This is the appearance browser selection options. So basically, if you look to the left, you have the material option here, and then the browser, and then the appearance option in the browser. So that's the easiest way to keep up with it. The only difference is I can have this part set to be made of whatever material I want, but I can make it visually appear however I want. So I could call this diamond plate, and it would be the density and volume of diamond plate, but then I could change this to be see-through color, and it would still be as heavy as diamond plate. You'll play with the materials in order to give designations for the actual densities, but the appearance is more something where if you want to see it in a certain way, you can have a little fun. So anyway, so this is wheel. And then next we have the axle. Boy, this is a doozy, isn't it? Okay, so I think we'll just do all this in one sketch and revolve it, just since it's such an easy part. We'll even put the chamfer in here, get all fancy. Yeah, I'd say that's pretty close. I'll just draw a random line through here and trim off the rest. Okay. So we have an overall of 78, and then the other portion is 55. All right. And then we have 20 and 24. Undo. Go ahead and put this perpendicular in. That did something crazy. Oh, we lost our chamfer earlier. How did that happen? Oh, I see. Okay, so let's just shift this over a little bit. It didn't have room to breathe, so it collapsed in on itself. All right, so now I'm gonna do my center line. Wait, you. All right, so we'll do vertical constraints to the endpoints again. Technically, you know, the center line, you wouldn't think it matters, but I like it to be tidy. You know, you don't want to just hanging out, being all ugly. It's better when it's just matched up to the part. It looks like you mean something there. There's intent when you're drawing, and you know, you always want to look good on paper. So 20 and 24. Unfortunately. Because I did that, you can't really do much about seeing it. So for now, as a placeholder, we'll just go ahead and put in our dimensions and ignore the terrible chamfers. Because all you got to do is just move them back in place. Fortunately, Inventor is, you know, very smart and flexible. So now we can go in and constrain our center point of that bottom line to the origin point. We can put in our chamfer values, which are 45 by 2. And we'll squeeze this in right here. I guess technically you could have set this one to equal the other one. Would have also been fine. Alright, so we're missing something. Probably this line. Yeah, okay, so basically what we need to do is say that these lines equal each other in order to make the part symmetric. So now that we've got that, go ahead and revolve it. Make the material SAE 1112. I have a feeling we won't be able to find that, but we can look and see. I'd be lying if I said I even know what that is. Okay, so this is a great example though. When you don't see something immediately, you can search for it. So let's try 1112. No results. Perfect. Okay, so let's see if there's just an SAE. Also nothing. Okay, let's see. So this is our material library. going to be in metal. There's really nothing for metal iron because, you know, obviously just that cast. Okay, so I guess we'll just look through here and pick something then. I don't know, let's take a Google real quick. So it's called SAE 1112. It's probably just some random alloy. Maybe type in material. Okay, so cold drawn steel. I guess this is what you would use when you're using a high temp, you know, like something if you were in Alaska and some ultra cold material that could withstand, you know, negative 100 degrees or whatever. Probably even just negative 40. Okay, yeah, so we'll just use some kind of cool steel. Those neat, but don't want to waste all day looking either. So we have stainless steel. Definitely not aluminum. You know what? Let's just do steel high strength low alloy. Does that equate to able to use in cold weather? I don't know. But where was that? High strength low alloy. There we go. Good stuff. Okay. We'll save that as axle. Click on one of these and steal that first part again. So now we've got it all. Let's go ahead and assemble it. So many parts. There's different ways to go about getting all of these. You can go in and do what I did there and just click on the name, hit Control-C to copy, click into the assembly viewing window and hit Paste, Control-V, paste it in. Or you can also choose Place and choose, like manually navigate to it and choose a part. Obviously, the downside of whichever one you place first is it's always going to ground it. You'll see that pin. So first things first, unground it as soon as you place that in. And then if you're having problems seeing, kind of like mine where the edges aren't clear, probably need to put it on shaded with edges. Makes it a little bit easier on the eyes. Okay, so we'll copy in the rest. That's my preferred way, you know, and you can even go in and open multiple at the same time too, depending on what you want to do. You're doing a place. And we need 2 of these, so I'm going to paste it twice. What we do now is, one, our assembly is actually positioned like this, and that this is going to be our basis frame. Everything ties in it, so we're going to use it for constraining to the origin. So, what's it called? The base plate. Find the planes in here, so we'll do the YZ for the base plate to YZ of Inventor. Boy, I forgot it does that little tink sound. I'm used to not working with the audio on, so that threw me off. So anyway, we'll keep going. Do XY to XY. And keep it on flush for these solutions. And last but not least, we'll do XZ to XZ. Okay, so now when you pull on this part, it doesn't move like the other ones do. So, you know, that's how you know you've fully constrained that part, is it just won't reposition itself. So now I'm going to go through, and there's multiple ways you can constrain these parts. I'll actually constrain these 2 differently to give you some ideas here, but you can constrain this part, this face. Then you can choose, I'm actually going to close this for a minute so I can find what's what. I don't advise constraining anything else to the main assembly origin. The reason being is if you deleted those constraints, you could move everything fully assembled together if you constrain all the pieces together. But if you constrained everything to the assembly origin, if for whatever reason things change, you would have to redo every constraint. So I highly advise you just basically constrain one part to that original assembly origin and then just close that folder and forget it exists. So now I'll continue going on with this constraining of bracket by doing a plane to plane again to locate it. You know, at this point you're going to have to be a little mindful to make sure it doesn't flip on you like it did there for me. And then I'm going to actually have to manually constrain this space to this space to make them flush. Now when I tug on this part, it doesn't flail. And you can see, you know, we've got a tiny little gap there, so it's flush on this end as intended. Okay, so I'll move this guy. I'll show you a different way to constrain the other bracket. There's many different ways always for these things. It's all about how you want to actually approach it. So this one, I will choose an insert. I will choose this circle here. So now what we've done is we've made the two circles tied into each other, both in location and the actual axis. So the only thing I would need then is to give it an angle to lock it in. You could also do a mate here as well, but angles are more flexible. And obviously that's quite a bit quicker, but it's kind of a bad habit to say that this corner and this corner match, because what if the whole part doesn't match? You know, it's actually better to do the constraining using planes like in this example over here. So now we will constrain the wheel. I'll put this little dude in a minute. And what we want to do is make sure that this is centered with the actual base plate, since again, that is what everything is located based on. I'll pull it back down a little bit. What I will say is the axis of this wheel is in line with the axis of the actual brackets. So now it should only spin, but you really cannot tell that it is spinning. As you can see now, looking at the planes, they're not aligned like they used to be. So then, if you want to make it not spin, you would go ahead and do an angle constraint. I like this option right here. It's pretty great, directed angle, because then you're just basically saying, you know, like I want it like this, or I can say 90. I'll spin at 90. You can do 270, 135. It's pretty great. But we'll just put in 0. Now, although you cannot tell, it's not spinning. And then I can actually constrain the axle to the wheel more or less. So we'll do an axis again. Choose the axis of the wheel. And then I'm going to expand that axle folder. Choose the plane that cuts it in half this way. And I will choose the wheel wherever it is. I'll choose that one. Alright, so now this guy also spins. So we need to do the same thing. And, you know, in this case, since you're kind of expecting it to spin with the wheel, if you wanted instead, you could actually just make it a mate. And that way, when you spin the wheel, it would spin this too, because they would always be in line with each other. But, you know, there you have it. That would be a wheel. Kind of looks like one a little bit. Obviously, it would be like a industrialized version. Alright, so now, I'd like to collapse these down. I'm done. Go ahead and save it. And we'll just take that name and delete off the excess. Our next step is to make view reps of all of these parts that we have in it. So we have 4 parts, right? Yeah, 4. Okay, so we'll go ahead and make a bunch of view reps here. And the reason for this will become more clear later, but basically we activate a layer, we choose whichever part we want, we right click it, choose isolate. You could also turn off the visibility of each one by one, but this is quicker. Lock that view, and go back to master, which is just regular, model. Or you can go to each part. I'm just going to go through and do this one by one. So I'll oscillate the bracket. I'll lock this view. I'll go ahead and jump to view 3. Isolate the wheel. Lock it again. And then I'll isolate the axle and lock it. Oops, I hit a wrong button there. What'd I hit? Oh man, I copied it to level detail. If you do that, just go in and expand this level of detail and just delete whichever one you made. So what did I do this for? Basically, when you're in your BOM and you're trying to tie things together, you need to be certain that your BOM actually matches. And the only way to do that is to have these view representations, because if you just paste the part in as is, it's not going to be able to account for it in the BOM. And that's a real problem. So this is the less than ideal but only real solution for that problem, is to, if they're all in one drawing, to make view reps. Okay, so what I went through and did is I double-clicked each one to turn it back on, saw what it was, named it accordingly. Now we'll go back to master, save it, and we'll fire up some drawings here. Weird how there's so many more metric templates than there are imperial, but it's fine. I'll go ahead and make 2 because I know we're going to have, I believe, we can get rid of that now. Yeah, we're going to have assembly and detail drawings. So, we'll have a base view, something like that. Then we'll do a parts list. Basically, to go through what's happening here, so I choose parts list, I choose a view, and then it's kind of going to have all these defaults, and those are great, so we can just go ahead and hit OK, and it's going to pop up that annoying prompt. You'll place your view, or BOM. So then it's going to have your accounting of stuff here. And the defaults on these aren't great, but we're not going to nitpick those right now, but eventually I will expect y'all to have different columns into one shown, and they'll actually be populated by editing the eye properties of the actual parts themselves. So like once you get done making these, you'll actually go through and fill out the eye property descriptions and stock numbers and anything else we may have. And then when you get back to your drawing later, it'll actually automate and pull that information over into your BOM. So it's going to be a lot of tedious work on the front end, but it'll solve a lot of the problems you'll have on the back end with your actual drawings. So anyway, make this one our detail drawing. And it's going to prompt you to save all the stuff that involves the drawing, which is every part and all the assemblies. So we'll go ahead and do that. And then we'll open up our other one. And yeah, so pretty sure we can change these later, but we'll see. So we'll save it. Change that to assembly drawing. Save. We'll close all this extra junk now. Since we saved it, it's not going to prompt us to save everything again, thank goodness. Alright, so now we're a little more lean. So we'll jump back to the detail drawing. This is going to be the one with the BOM. The other one will not have a BOM. So we're just going to simply bubble each item. And, it's kind of frowned upon, but I would prefer you guys doing this. We work in, 2020, so people actually like isometric views. It's great because you can see a lot more depth that you couldn't elsewhere. So we're going to bubble everything in the isometric view. I'm not trying to make these perfect or anything, so you do you. And if you're thinking, oh well, it's kind of hard to see that pin here, well, you can bubble them somewhere else too. It's a little redundant, sure, but sometimes it is hard to tell, and a little more feedback would be appreciated. So nobody's going to judge you there. See, if I detail these, for instance, like, yeah, sure, no one probably needs it, but at least it's there. I can tell from here, but some people may not be able to. And then, you could also do this. You could move it over, edit the arrowhead, set it to be, I don't know why these are squished, but oblique. And then, it kind of says, like, this generic area here is that pin, axle. Actually, I'm going to move it in. It's kind of gross way out there. Okay, so since the detail drawing, the only thing you really need to do is more or less say, this is where things line up. So we're not going to go too deep in it. We'll just say, actually, I'm going to do a center line here as well. We'll just extend it out. Sometimes, in Inventor, you don't have a lot of choice on your edges that you have. So the only thing we'll put is like the location to the top. And then, like constraint-wise, there's really not much to say besides, like this is flush, so I guess you could say it's roughly this wide. Like maybe they want to know the widths here for some reason. I don't really, like what would be the point? So we'll just do these edges too. And really just about all you really need is just basically like generic overalls. So we can give a height here too. It seems silly, but now sometimes the center marks may get in the way, and if they do, you may just have to pull them back. Super annoying, but Inventor's pretty notorious for that. So if you're having that issue, just go wiggle and pull back when you're done. All right. So you're probably thinking, man, that's it. But no, it's totally not. So we actually need a sheet for each part. I think there were 4. So now we're going to do another base view. And then you see it's got our assembly pulled again, so we don't need to search. We're going to actually choose in this view rep column. If you notice all these representations, we were talking about those. View rep, position rep, level detail. We need to go through and pick one of our parts. I believe the first was base plate. Double check. Yeah, so we'll do base plate. And then make sure you check this associative box. What that does is it keeps the part up to date if something is to change. I forgot earlier to put in our view label, so we'll have to go back to the other one and do that. Let's give it a scale. And we'll do something like these views here. The scale is really kind of small too, so we're actually going to change that. Something like that's a little better. Alright, so wheel assembly. Now granted, you guys are going to be using all caps, but I don't have to, so that's pretty cool. Alright, so put in our constraints, our center marks, and dimensions. Gotta wrap these up as quick as we can. You know what? Let's put on hidden lines on all these. Yeah, okay. We'll leave this one as solid though. That gives a lot more information about what's going on there. We'll do the same for this one. We'll leave the isometric as solid. So now we kind of need to put in our center lines. I always love a top view like this where you can just dimension everything. I'm not actually going to put the dimensions here and here and vice versa. Well, you know what? We may as well. I was about to say, because really it's understood that they're concentric, so you really don't need it. But you know, sometimes people may not be sure. So we'll do quantities of these for x, for x. We'll reposition the view label in a minute. I think I'll just move these roughly in line with each other, actually. Okay. Then I think that's it. Okay. So one thing we're missing still is a bubble. Like, how do I know that Baseplate is tied into that parts list? Well, I have to have a bubble here. So now I know if I go and look here, item 1 is this. And the whole reason we did the view rep because it won't count for which item it is if you don't do it that way. The view reps would actually just show that they're all item 1 instead of saying what it actually is. And you'll see that with the next one that it actually does account for what's going on. Now part 2 is the wheel. Make sure you check that box, turn on your view label. Let's do 1.5 again. We'll just do an ISO here. And rotate this because I should have done this view. Now, this is a great time to do a section view because it's a solid part that's revolved. So we're going to just choose the view, draw a line, pull it some way. Now I've got this wonderful, wonderful view. And now I can detail it. Okay, I was thinking that. I should have actually kept that Word doc open earlier. So we'll position this around a little bit better. Maybe something like this. It's fine. It's not great, but it's fine. Okay. Move the view down a good bit. Remember, you use all caps. I'm only going to have one view label on, but I will go ahead and put my bubble before I forget it. I believe, yeah, okay, so we need to rotate this. When I changed my view rotation, it didn't rotate this, so make sure you do. Change it to this position, put the bubble, center mark, center line, and let's dimension this bad boy. You can dimension it however you want as long as you get every single detail in there. I'm just going to dimension it like the book, just since that's the likely way that you'll go about it yourself. I don't think we'll be able to get this dimension without some struggling, so we'll probably have to manually do a sketch to show that it's the vertex. So what you'll do is you'll click the view, start a sketch, project the geometry, these two lines. What we'll do is continue along those paths of those lines. If it's hard to get it right, just draw like a random line and then just make it collinear here. That's a bad example because it formed its own perpendicular constraint there. But I'm going to draw a random line and then I'll make it collinear. Trim. And then we'll make this, well, you know, it's really not very visible, but I guess we will. Click on and choose properties. I just need to click one. Yeah. I think it's grabbing the section view every time. just right-clicked it and chose properties. Okay, so let's try dashed. That's kind of crap. I like dotted. Dotted sounds like a good idea. It's really terrible too. Okay. We'll just keep it and make the line white, or we'll change the color. Make it more gray. There we go. Not abundantly clear, but I want it to be because you don't want to cause too much confusion either. So. Alright, so let's see, what else are we missing here? Okay, so we also need this width here. We already have it. Okay, so we need this width. And what I'm going to do is, terrible as it looks, pull it off the model. That way it's more clear. You can, see it here and just jump over. I think that's about it for this one. Let's double check the drawing. Okay, so we do need one more thing after we adjust this view label back up. We need to fill its note. I'm going to choose a leader text. Typically if you click and then you move around, you type, or you right click after you click around, you type and it makes a note. But what you can do instead is actually choose leader text and double click. And it'll just make a very easy to manipulate label. So using leader text is great there. I'd probably make it a bit bigger though. So now I can double click it. Let's make it 6 millimeters. Alright, and I copied that in case we have another one to detail with the fillet on it. Let's see, part 3 is the bracket. Definitely got some fillets. So we'll go ahead and paste that on there. Alright, and man, this thing's got a lot of detail. I like to typically place the views in the position they are in the model, so I'm not going to rotate that at all. I think I will rotate it to the other side, actually. Okay, so just like how they detailed it, we're going to flip it to our back view here. That way we can have this useful view. And I really hate having a top view like that, but let's see. I'll look if we position it this way. Yeah, it's fine. We'll actually commit to it. Alright, so I want you guys to all do this, but if you notice we've got these incomplete edges everywhere, it's because we need tangent edges turned on. So when you're sitting on your view thing, like after you double click this view, go to display options and enable tangent edges. What that'll do is it'll show all these goods that we need. It might be a bit much, but at least you can see what's going on better. I turned on hidden lines again. We're going to scale this up. We already did. Okay. Name it bracket. And let's do a projected view and get that ISO in there that we like. Alright, so then it's just detailing again. After we put on our center marks. So many center marks. We need center lines. So make sure you get all of them. Pretty easy to miss some. Okay. So we have 48, Actually, I did the bad right there. Make sure you're choosing the center line. Just because I like to be safe, I'm going to add in this extra one of 61. Then we will put in this one, which will have a 2 times beside it. Put in these. Make sure you don't grab the midpoints like I almost did there. Let's do this dimension. 12 here as well. And this might be tough to detail as well. We'll probably do a sketch again. As much as I hate to keep doing these, sketch is really like not an intended thing, but when you have fillets like this, you really don't have much of a choice because the only way to have them in there would be like to dimension it ahead of time and then like unsuppress the feature or suppress it, add it in. You could also have like a pre-drawn sketch annotation you pull in or a model annotation, but if you're wanting to just purely detail, you don't have a lot of options. So just draw this line, make it collinear. Then we can trim it. Then we basically just have this line. We'll make it gray again. Yeah, so remember, just hover over, right click, gray. Alright, so where are those values? So we just had a width and a height. Ah, son of a gun, we'll get there too. Okay, that's fine. So double click the sketch to edit it. Project this edge, linear. Alright, same deal. Slap in our dimensions. And we'll need a width of that. Plug in the quantities. But you know what? These are actually special. I forgot about that. Okay, so time to talk about the hole and thread command. So notice when I click the hole and thread and I click here, it gives us this information. We have a 10 diameter hole that is 8 through all, basically, but minus the. Okay, so basically it's through all, but it's the difference of this portion and that portion. And then we've got the actual spot face 15. So what it's more or less saying is this portion is 10, but the spot face is 2. So I need to add a quantity in before I forget, but I was thinking about this. So basically, if you use the hole and thread command, it'll actually fill out all this. And if you don't like the way it's laid out, you can actually edit the quantity note, or you can top or add here. But obviously, it's cool when it automates it, so don't mess with the actual pieces it pulls. Our circle's dimension still, I see. We're missing 4 dimensions. Never be scared to reposition things to make it look better. No quantity needed here, since obviously there's really just one. And last but not least, the axle. think we can go a little bigger. You know what? Since all the other ones are 1.5, we'll keep this one the same. So now we need our center mark, and we'll just do a center line. Actually, I like the bisector a lot. It's pretty convenient, but balloon. It's kind of ironic, but so one thing you can do if you want these to be sorted a certain way is you can go into your BOM. You can choose the A to Z option, choose sort by, and you can choose part number. Choose sort. It's up to you. I don't know how they were actually done in the book, but if you know, for instance, that you want something to be a certain item, you could say, let's do it like they have it. So baseplate's 1, wheel is 2, brackets 3. I think I was typing in the wrong place. Okay, so I'm just going to clear those. Baseplate was 1, wheel is 2, bracket 3, axle is 4. So now I can choose sort, choose by item. I'll sort them to match the actual book. So now when I go to the last page here, like ideal, we have the actual last item here. So basically, as you go through these sheets that you see, you have sheet 2 is item 1, sheet 3 item 2, sheet 4 item 3, and so on. You know, when you see the lightning bolts, that means you need to update. So there's this button up here to do so. And the only reason they're updating is the actual BOM item number was updating on their end. So this one's pretty basic. We just need our widths, and then we will do, I guess we'll dimension it here. I was kind of tempted to do the other one over there, but because of the chamfer, it's not as clear. We'll dimension these, and if you notice, it doesn't include the diameter symbol, so we're going to edit those, add in the diameter symbol. Oh yeah, and then we'll add the chamfer. So just like the hole command, there's also a chamfer command. So I'm going to choose an edge and an edge, and click and place. And then I'll just make sure to go to the front of all of this jargon and type in 2x for the quantity that we have. Alright, so now we'll reposition everything. It is still a little small though. I think we'll size this one up, even though, you know, it'll be a little bigger than the other ones. It would be very hard to see for somebody. So we'll size this one up to match. So that does look better. And if you notice, our dimensions actually, for the most part, kind of proportionately scale with it. It's not perfect, but it works out pretty good. So now we'll move it around, make it look a little better presentation-wise. Now, if you go through and look, we've got each item detailed. So now you would fill it out and then update your BOM items to match. I'm not going to nitpick that too much for this one. Alright, so now for the assembly part, we're going to actually have to go back into the model. When I was showing you 2 different ways to constrain earlier, it was really just to show you different methods, but you actually won't be able to do the exploded model with this part constrained how it is. So we're going to delete the constraints that exist and constrain it how I would prefer to constrain it anyways. So we'll go ahead and expand these folders back out. Constrain that face to that face. Constrain the plane to the plane. And then constrain these 2 faces. Okay, so now that we've done that, and for whatever reason, this isn't our home view, so I'm going to set this view to be my home view. That way when I can hit the home button, it actually will position it back where it should be. Okay, so now that we've done that, we're going to make exploded views. And in the book, it shows a different method, but it really doesn't work well. So what we're going to do is do a new position representation now. I know we've been doing view representations, but now we're going to actually change the way things are located for the sake of an explosion. So exploded. So it's still active. So what I'm going to do is I'm actually going to leave this part where it's at, and I'll move the other ones away. So what we're going to do is go and find the constraints that locate it. So for instance, this part, it touches that face there. So I can right click and choose override. I can choose to put in a value. I can say like 100 millimeters, and what it'll do is it'll actually relocate it. That's a little big, so I'm going to slowly one-time click it. I'll just choose 50. It seems better. So then I'll do the same, and I'm just basically going to override a bunch of values to move them. We'll say 50 here as well. Minus 50 since it went the other way. So then basically to move over and up. Got a student blowing me up. Bear with me. I think if I choose modify override, it may skip that dialog box. So let's take a look at that. Yeah, okay, cool. So choose modify override. A little quicker. Just the wrong one there. Alright, so now it's kind of starting to look exploded. We will do what we got here. I don't know if this one will work, but we'll try to do it. Modify override 50. Hey, it did. Okay, cool. So we'll do minus 50. If I chose the right one, that would help. Minus 50. What the French toast? I think that's actually constrained to the axle. It is. Okay, so how is this wheel constrained? This is one of those things where you just gotta look and see what you did, you know? So we have mate there, angle. That's weird. Okay, whatever. It doesn't change whether they do 50 or minus 50. Not be the problem. Let's go back. Did I delete a constraint earlier? Wow, I must have. Okay, my bad there, everybody. So now we have that locked in again. Let's go back to the exploded view. See, actually it updated already. So we've got our wheel. I think I'm going to leave it like that, actually. That's not bad. We'll move this part out, of course. This one might be kind of tough. You know what we'll do is we'll just actually shift it over. 50. Let's do minus 100. Okay, and then what we'll do is we'll shift this one further over. So let's do minus 150. Yeah, that looks good. Okay. So now what we'll do is lock that exploded view. Apparently you can't, so we'll just go to master. Then what we can do in our, not our detail drawing, it's done, so I'm actually just going to save and close it. And this one, we can do our drop down for position rep and choose exploded view. really, since this is the way it is, I see no point to even have any other view, really. Let's see, what would it look like if we kept one view? It's not bad, but you know, I don't really see a point. It would actually be better to do a presentation, have like the lines that connect. But since you guys haven't got into that yet in the book, I'm not gonna try to make you just blindly work through it. So we'll just do an isometric view. We'll do a parts list based on that view. And then it'll just be ballooning. This is one cool thing is assembly views or assembly drawings are very easy to recreate. You know, it's kind of just getting creative, finding the places. Now, given in another class, you'll be doing a lot of assemblies, and we will be going through how to make assembly views and filling out all this BOM data, but you've already got plenty to do in this class, you know, so that's pretty much going to be it for this one. And let's just jump in and see what's next here on the docket. I don't know how that got switched to there. Okay, so we've got a vise assembly. And quite a few parts, it looks like. Try to keep this short. I'll probably just do like the placement for everything, and then let you guys do the rest from there on the detailing. Y'all obviously know how to detail, so this one's going to be inches. Sorry about that. My allergies are crazy lately. All right, so that's our front view. So we're going to draw this portion on that front view. It looks to be fairly straightforward, just like a block. Watch my last line. We'll do something like that. Okay. So, what do we have to work with? We got 5.25 here. Let's start. Hopefully that'll scale it. And it did. Good, good. Alright, so we got 1.25, 1.5 for a radius, 2.625 to the center of that circle. It's too tall here. It's 3 to here. I'm not drawing the ground portion yet, so. And I suppose we'll actually just locate this bottom line, the center of it, to the origin. Nothing crazy. We need a tangent. And this center point is aligned to that edge, so we'll set this center point to be coincident to the line. And that's it. It's fully constrained. I prefer when you have an overall value, but sometimes you're not given that, so you just got to work with what the house gives you. Screw it at 3.5. Go ahead and draw these little tabs on here on all 4 sides. I didn't even realize there was a node actually, so slots cut through entire base. Good to know. Okay. And it's cast iron. Let's go ahead and do that before we forget. I don't think there's more than one option. iron gray. The only reason I know that that's what we should choose is actually because when we were in the material browser earlier, the only option it showed for metal iron was this one. So make sure you choose an iron gray here. So now we can go back to that sketch. Make our little feet. Huh. I actually didn't mean to snap that tangent, but I'm not sad about it. Slice graphics if needed to see what I've projected. So this portion is 0.5 from the very end. .625, 0.375, 2, I'm going to locate it to center it up. And we're missing one more dimension here. And that is going to be 0.625. The center to the edge. Oops, I clicked. Alright, so we have the same thing over here. Instead of drawing that entire thing again, I am actually just going to mirror it. So I believe it was 0.375, but we'll double check. So I'll go ahead and mirror that across. Extrusion 2, mirror plane, YZ. Extrusion 2, mirror plane, XY. But you know what? Actually, this one should also have mirror 1. Okay. I've got our 4 tabs. So now we need to add in this little portion and that cutout. So I think that we will draw the circle first. Really hard to see. I didn't notice beforehand, but it appears we're actually going to need 2 features here, which is kind of unfortunate. That's weird. I've never seen them a different color like that. Huh. Actually, really strange. I'd like to know what that's about. It's got to be new. It was 0.625. Ah, this one's a radius. All right. So we'll trim this. Extrude. This one's going to be 2, that base. And this one's going to be a cut, that same face. Turn the sketch back off. And let's do that final piece. It's a little cutout. I'll tell you what, you can't see a thing over here. best to try to follow and make sure you're seeing that it's perpendicular as you go. Alright, so project the bottom edge if it's not already. Trim. Alright, so it's a little wonky, but let's just kind of shift it to be closer. Put in a collinear. Set this to equal this one to center it. We need to take the center point and align it to the projected center point, and that'll fully constrain it. So now we can extrude it through all and cut it. Sometimes it's finicky and it won't let you do both ways, but we got there in the end. Alright, so let's save that. It's going to be Vice Assembly Base. Next we've got the jaw. I believe, yeah, we'll do a side view here, which is really, that's going to be our front view, but we're going to draw that side. Okay, so it's going to be roughly something like this. And a random arc. We'll just make it a little closer. I don't like to try to imply any constraints. You never know what it's going to be. It's not like I'm looking at these ahead, you know. Okay, so I do know that this is going to be coincident, though. Alright, so we've got overall height of 3.75 if you add everything up there. It's going to grow a lot. We've got a radius of 1.5. And it's aligned to that line. They give you a dimension to the rest of it. So we've got 1.375. It's 1.75 wide down here. What am I missing? First of all, I want to move and put this point here. Did a little goofy thing, but okay, there's what I'm looking for. I'm looking for this edge. Okay, so it's 2.75 to here. There we go. All right, cool, cool. It's not tangent, as you see. So we will extrude it an overall width of 3.5, and then we'll cut off the rest there. Alright, so kind of generically draw these. You know what? Actually, I'll draw one and I'll mirror the other. It's a lot less work. It's 1.25 overall width, so I'll just do a dimension that is 1.25 divided by 2. Slap in some collinears. box itself is 1.75. But then we have a box in our box we need to draw. .75 to here. .875. I read that wrong. 0.1875. And the same here. Let's see, what else? What else? We need 1.25 here. And this is collinear to that. Alright, so cut through all both ways. Being finicky with that. If you're having problems with both ways, do like I did there and just give it what it wants and say the direction. Shouldn't matter, but I don't know, it seems to be occurring sometimes. There's that, and then we need to extrude on this little tip here. We've got, oh, it's not a through all hole, that's interesting. So we'll do two features here, that's fine. So it's a radius of 0.75. And it tells us nothing about the location, so we have to assume that it's in line with that edge. And I guess if you're feeling froggy, you could trim this. But you have to make sure here to choose 2 and choose that next face. That way you get that perfect union. Then we're gonna project this, and we'll just do a point this time. That way we can use the hole command, which is always easier when you have depths and things of that such. So let's see. We have 0.75 at a depth of 5.5. And as I mentioned, you know, it likes to keep these old settings, and it's just terrible. I don't know what the deal is with that. It is what it is. So make sure you go in here, and if you're having that problem, make sure you type in inches with it. 0.75 and then 0.5. Kind of just reluctant here. I'm going to hover. It's going to tell me. There we go. Okay, so I've got that. I think that's it. Yeah, so that's the jaw. Huh. So then we've got keys. I guess we need to draw these little lads here. It actually gives us some information. Also, before that, let's change this material to iron gray. Save it again. Make sure that this was. Yep. Okay. Now we'll make those keys. And what it's given there is like some information, not only about the size, but actually the constraining location for it. So that's good to know for whenever it comes time. I'm going to draw everything on the same face, match this part. So we'll do a front view of this too, I guess. So because it's just a rectangle, we can use a 2-point rectangle. And it's going to be 0.1875 high. 1, 2, 3, 1. 0.3125 wide, which is this direction, and then 1.75 long. Right, so then our extrusion is 0.3125, basically 5/16. Okay, so and I just call that one key. All right. Now we've got the screw. I suppose we'll just do one big revolve on that one. All right, so I guess we'll just draw a generic kind of barbell shape. And extend, trim. Let's go ahead. It might break it. We'll see. I just want to go ahead and move that to the origin point. Okay. I don't know if you see, but there's a little extra in there. That's why I like to draw it out in space and move it, is because you can't really see because of these lines. So keep that in mind. All right, let's make sure it's still recording. Okay. So overall width of 6.5. We have 0.5 on one side and 1 on the other. And now seems like a good time to go ahead and draw in our center line. I'll resize it in a minute. For now, I'm just going to leave it as is since this part's touching. What's going on here? Strange. Let's check that again. What? I did nothing different. Okay, that's cool. Sometimes life is a mystery. So this one equals this one. Oh, it already knows they're collinear. What do you know? I didn't even apply that constraint. It doesn't say that they're equal to each other, but they clearly are. What's even more strange is I could have swore I located this a minute ago. It's all good. I'm going to undo this crap. This is just hot garbage. Okay. So once you have no center line again, change the line that exists to a center line. I try to keep it separate for a reason, but obviously it's getting to be difficult. So find the center, wherever it may be, constrain it to the origin. Now we'll put in the 0.75 and the 0.625. I don't think it'll let you do a revolve without turning it. I guess it will, but if it's an object line still. Learning experience for all of us. Okay, so now we need a chamfer of 0.0625, 45. And if you read this note as we've been going along, basically it's saying that ends flat and talks about some constraining again. But basically, this part has a chamfer. We do need to change material to alloy steel. It's probably called steel alloy. Yep. So we'll go ahead and do that hole though. I'm sure that's what most people are curious, is how do you get that hole like that? You just draw on the plane, draw a circle, extrude it out, nothing crazy. Obviously you've got to locate it. That part can be kind of crazy, but it's 0.5 and then the size is 0.375. Unintended. I hate when I jump like that, but that is actually a problem that Inventor has more so than SolidWorks. Alright, chamfer time. Alright, so I chose there a face and a edge. And that appears to be it. Okay, so that is called, generically, screw. So next we have handle rod, and let's see what it says about that. So the handle rod was that little thing that came through here. It's talking about, again, how it was constrained. And then basically the rest is on us. But I realized now I probably forgot to give a material. I did, to the key. So let's make that alloy steel. Okay, just making sure we got all of them since really missed that a few times. Handle rod. Okay. Doesn't really give us any information about it, so I guess we'll draw this one just on the front plane. We're just going to do a basic extrusion. That size is 0.375. Okay, so it's going to be 5 long. And I believe it's an alloy steel as well. Yeah. Alright. And open. So that is called handle rod. Or so many parts. Next up, handle knob. Constraining info again. I'm just going to draw the part. So I'm going to commit to the same view as, or the same positioning as the other one, but I'm going to do a revolve. So we'll draw it from this view. It looked like it had chamfers. I'll double check, but so we've got 0.75 overall. Diameter 0.625. Chamfers of 0.0625 by 45. An extra 2 in there. Just going to grab the values from the other ones that we did. All right. And we've got a hole. It's only partially through it. I guess I could have done it in another view, but I'm fine with just doing it here. So it's 0.375 at a depth of 0.5. And the way I'm going to locate this is I'm actually going to choose the end of this face so that whenever we're constraining to the rod, we can just constrain to the plane in case it's hard to see. It may not be, but kind of just be a little preventative here. It's a steel alloy. Obviously, we're going to leave that middle portion open. So this one is asking for the axis, which it suddenly grabbed. Okay. Now we'll save it as handle knob. Okay. Cool. Okay, so now we can go ahead and constrain this bad boy. It's a lot of parts, I tell you. You know, in the future, when you're really drafting, you'll have way more, but for the sake of a video, quite a few. Alright, so that's weird. I never used that. Okay. We'll just grab them all in one quick go. Last assembly stuff. Place it all in one big old glob. Also, the perk of doing it that way is it doesn't ground anything either. So that's kind of nice. So obviously the fixture for this entire assembly is the base. So that's what we're going to constrain to the origin. So it should be easy to just go into YZ, YZ, XZ, XZ, XY, XY. There we go. So that one's pretty straightforward. As mentioned before, if your view style like mine doesn't have edges by default, please, for your own sake, add those. Okay, so let's see what's related to what here. Obviously, we know these all share the same axis. That part's a given. But we had some random notes in here. We'll go ahead and constrain this one pretty easy. Key fits in, flush, blah, 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 blah. Okay. We'll copy that. And 3D mouse settings aren't great. I just never set up this Inventor after I got it, so. Weird, it doesn't look like it has a material. There we go. Since it fits perfectly, I can just kind of lazily constrain the faces together like y'all saw me do. Don't have to worry about doing planes and all that good stuff. And somewhere over here it's out in space. Yep, see the faces are aligned now, but they're just really far away. We're getting warmer. And this one I need to change the solution to mate, where I missed a selection. Okay, what are you doing, computer? What are you doing to me? Okay, I see what happened. Somehow I grabbed the wrong face earlier. So we're going to go in and delete that. Or rather, it looks like I made, instead of a flush, it should be a mate. As you see when I flip it now, it's oriented the right way. Flush. Man. I mean, just laggy. Can't believe I was like... Okay, whatever. So, save. Always good to save periodically when you think you've got a good point going. I think we do. So, just grab that name. Let's see what else we have here. So that's got the slots fitting. Flat edge is flush with the recessed 0.75 face of the jaw. I believe it's saying it just basically fits in this hole. Yeah. Okay, so we can go ahead and constrain. Man, I've got to tighten up that sensitivity a little bit. Don't do what I did there. The second selection was the center point. It should be the actual face inside of there. Make sure you don't see that green dot. Okay, so now we can then do an axis constraint. Now it just spins, and that's it. All right, so let's see what else we got here. So the way it wants it is it wants everything locked. So let's see how that handle is oriented. It's at 30 degrees as well. So we'll want to commit to that based on that note there. So this is going to be an angle constraint like we were talking about earlier. That is going to require, you don't necessarily have to use planes, but I sure would use them to be safe here. What was that one called? Screw. Okay. So to turn on the angle constraint, we're going to choose the horizontal plane for the key. And then basically the horizontal plane that cuts through the hole. Naturally, because that part isn't constrained, it looks a little goofy, but if you're looking at it, I think it's supposed to be angled the other way. Let's check. So angled down to the left. So we'll do either 330 or minus 30. We'll fix the jaw in a minute. This should do it, just doing a axis constraint here. Okay, so now like it still spins, but a little more effectively. So now what we can go ahead and do is take the jaw's center plane and constrain it to the center plane of the, I'm guessing base is what it was called. Yeah. Base is such a common term, but I'm really not a huge fan of it, honestly. It's just so generic. I feel like you can give more information, you know, but it's fine. Okay, so we've got this guy. We'll copy another one of these. And then we'll constrain the axis to the axis. And you know, we can actually go ahead and put these little caps on. And we're going to use an insert for this one. Do the same for this side. Basically, as long as you choose that inner edge, you know, you're pretty good to go. Now, granted, they spin freely, but it's really hard to tell what you can see. But you know, for the sake of how it's covering it in the book, we'll constrain these two. A lot of times, like in the workplace, you're probably not going to even bother. This is one of those things that it just takes more memory, and you know, it's not going to affect anything if it spins. But for this sake, we're gonna keep this true to how, you know, the book has it. I think we're done with the screw, so I'm gonna pull it out, close the jaw down, handle rod. There we go. We'll do an angle, undirected. We'll do the same constraint again, but for the other side. Where is the other handle knob? There it is. Cool. Okay, so now we have non-moving those. The only thing we need to do is locate this. And I believe it just has it centered, but still check. Oh, it's just arbitrarily offset. Awesome. Okay, so the handle is aligned with the screw so that the outer edge of the upper knob is 2 inches from the central axis. What it's trying to say is this face to the center should be 2. So I'll try to do that same thing and just say 2 minus 2. There we go. So the only thing that should happen is we can still move this freely. I don't think it gives us any location on the jaw. Flat surface of the base and the jaw opening is set to 1.5 inches. Okay, so it wants 1.5 between the teeth here, if you will. I guess jaw in this case. Go. Now nothing moves. Very, very nice assembly, if I do say so myself. And I'm just going to right click up here and hit collapse all children to collapse all those in one quick move. And then I'll set up the drawing, and then I'll let you do the rest, you know, as far as the rest of the work goes, you know, the detailing. Having a lot of lag though, for sure. Let's see what the top view would look like. Let's just check it out. Something like this, you never know what views you'll need. I really like the top view a lot. But we're actually going to keep all 4 views, yeah. So make sure you've got your view label on it. Device assembly. Be like me and things wrong. And I've already forgot something. This is where we get to do view reps again. Delete this default if it gives that to you. That's so annoying. There's a reason you have master. Okay, so we've got 1, 2, 3, 4, 5, 6, 7 parts. So 1, 2, 3, 4, and 7. Okay. So we'll name this one base, handle, knob, handle rod, jaw, screw, and that might be it actually. Okay, so go in here, double click on each one, right click, isolate, lock her down. Do the same, just go throughout and do each one. And if you notice, you can also do it in the browser. So if you don't want to go through and try to actually find out which one's which, you can just pretty much match the words, which is what I'm doing here to save a little more time versus trying to scan around for each one. And last but not least, the screw. Okay, and remember, always go back to master before you're done. Yeah, it's one of those things. It's just consider it shopkeeping. You got to do it. All right, so we've got 6 of these, so we need to have 7 sheets total. So sometimes we make it that prompt. Let's go ahead and put in our parts list. Yep, good stuff. And let's number these like in the book again. Let's see. So we've got bases first, and then jaw is second. Oops, wrong column. Screw is third. Handle rod and then handle knob. Did I miss one? Ah, the key. Missed the key. Daggone it. Okay, so 3. I'm live sometimes. Okay. 4, 5, and 6. Okay. So now we can do the sort by item number. Okay. I guess we got base, jaw, key, screw, handle rod, handle knob. Good stuff. So now I want you to place those in that same order. So base first. And let's see, we'll probably just get away with these two views here. Oh no, that's right, we need a front view here too. Part's got a lot of detail. A lot of detail. Make sure, you know, after you get done detailing, to put your bubble. Gotta have it. And let's see, the jaw was next. Let's see, kind of think what you need here. You might not even need all your views here. Wrong way. Yeah, actually, I would just say delete that view. So anyway, you go through, do the same, detail everything, bubble it, etc. Just like before, I'm not going to make you watch for 30 more minutes, you know, for me to do that. Make sure in this one to locate the handle, locate the teeth in reference to each other. Everything should show actual positioning. That's the intent for the detail drawing. So, you know, obviously you would need your 1.5 inches. You would want your 30-degree angle, your positioning from the center. Everything it told you that was relevant, you'll actually need. And you may have to be creative to show these teeth, for instance, or, you know, I guess you call it the key and how it aligns, stuff like that. So try to capture all of that, bubble where necessary to show everything. And yeah, once you get done, you'll go back to your assembly and you'll do the position reps, making an exploded view. And then just like before, you'll go through and find whatever constraints and you'll modify, override them, type in a different value. I don't know what I offset there, but something happened. Basically, yeah, you'll proceed and do the same thing there until you have an exploded part, and then in a assembly drawing, you'll place that exploded thing and bubble it. So that's pretty much it. I'm gonna save this out and then I'll call it done here. Yeah, make sure you hit yes to autosave always. And don't ever leave it in a position rep. Alright. Well, thanks for watching, everybody.